Hello everyone, my name is Shankar. This video we are going to see about one Dijkstra algorithm to find the shortest path from single source to another vertices. We are using class name as graph in here. So after that we need init. So I'm just using def init of self. Then self vertices is empty brackets. Then we need we need to add vertex. So we are using def add vertex self comma key. Then vertex is equal to vertex of key. Then self dot vertex of key is equal to vertex. Then def we need get vertex. So we are using def get vertex. Then of self key. Then return self dot vertex of key. Then we need to use we need contains in here. So we are using def contains. Then self dot keys. Then return keys in self dot vertex vertices. Then we need add edge. So we are using add def add edge. Then self dot src key. Then dest key. Then weight is equal to 1. Then self dot versus src key. Then add neighbor of self dot vertices. Then dest vertices of dest key weight. Then def does edge exist self src key. Then dest key. Then return self dot vertices src key is then does it point to then self dot vertices then dest key. Then def in enter. Then self. Then return enter self dot vertices is equal to vertices dot values. Then we are using the second class. This is vertex class. In here also we need init. So we are using def init. Then self dot key self comma key. Then self dot key is equal to key. Then self dot points 2 is equal to empty brackets. Then def get key self. Then return self dot key. Then we need add neighbor. So we're using def add neighbor. Then self dest weight. Then self points to dest is equal to weight. Then we are using get neighbor. So we are using def get neighbor self. Then return self dot point to key. Then we need get weight. So we are using def get weight. Then self comma key. Then return self dot points to dest. Then we need does it points to. So we are using def does it points to self comma dest. Then return dest in self points to. Then we are using Dijkstra. So we are using def Dijkstras. Then Dijkstra g comma source. Then unvisited is equal to set g. Then distance dict dot from keys of g float of enough. Then distance source 0. Then while unvisited is not equal to set. Then closest is equal to minimum unvisited. Key is equal to lambda. Then v. Then colon. Then distance v. Distance of v. Then unvisited dot remove of closest. Then for neighbor in closest dot get neighbors. Then if neighbors in unvisited, then new distance of closet plus closet dot get weight of neighbor. If distance of neighbor is greater than new distance, then distance of neighbor is equal to new distance. Then just returns the distance. Then we are using g is equal to g is for graph. Then print menu. Then print these are the things which will be in the output. Print add vertex. Then key. Then add edge. Then print shortest. Then print display. Then quit. Then while true do is equal to input. Then what do you like to do? This will be the user input. Then dot split. This will be the user input which will be in the output there. Then operation is equal to do of 0. If operation is equal to add, sub operation is equal to do of 1. If sub operation is equal to vertex, key is equal to int of do of 2. If key not in g, then g dot add vertex of key, else just prints vertex already exists. lf sub operation is equal to h. If sub operation is equal to h, just goes here. SRC is equal to int do of 2, then dest int do of 3, then weight int of do of 4. Then if SRC is not in G, just prints vertex does not exist. If it just the does it not in G, then does not in G, then vertex print the vertex print does not exist. Then format dot dest format of dest, then just comes for else statement else. Then in else we are using if and else here. In if we are using not G does not edge exist, src does dest, then G dot add edge is add edge of src dest weight, then G of add edge dest src weight, else it just prints edge already exists. Here LF operation is equal to shortest. This is for the shortest operation here in the output operation for shortest. Key is equal to init of the do of 1. Source is equal to get dot get vertex of key. Then distance is equal to Dijkstra G comma source. Then print distance from. Then this way it will be printed in the output. Then format of key. Then V is in the distance. Then print distance to. Then format V get key. Then distance of V. Then print elf operation is equal to display. Then print vertices. Print of vertices. There it will be in the output. Then end. Then V. Now for V in G, print V get key. End. It will be in the output. Then end. Then print just print the edges. Then V for V in G, for dest in V get neighbor. W is equal to V dot get weight dest, then print src dest weight, then into then for format V dot get key of dest get key, then W, then print, just prints everything. Or else just comes for LF operation is equal to quit, then just breaks everything. If we just give quit in here, it just breaks everything, and menu driven program will be exited from here. We can just run the program. At first it's just asking what do you like to do. I'm just giving add vertex. Add vertex is the thing what I want to do. Add vertex 1. Add vertex 1. Then it just asks again what do you want to like to do. I'm just giving add vertex 2. Then what do you like to do. I'm just giving add vertex 3. Then just asks again. I'm just giving vertex 4. Then it just asks again. I'm just giving here. I'm just adding the edge. First I just add the vertex, then I'm just adding the edge. So add edge, just adding the edge 1, 2, 10. This asks again 2, 3, 20. Then I'm just giving add edge again, then 3, 4, 25. Then I'm just giving the add edge again. Here 1, 4, 34. Here just asks again. I'm just giving shortest 1. Just shows the distance from 1. 1 to distance from distance to 1 is 0. Then distance to 2 is 10. Then distance to 3 is 30, and distance to 4 is 34, which means 10, then 30, then 34. This is the distance from 1 to 2, and 1 to 3, and 1 to 4. Then just ask again what do you want to do. I'm just going to display everything. Display just displays everything. Vertices is 1, 2, 3, 4. Then SRC is 1, dest is 2, then weight is 10. Then SRC is 2, dest is 4, then weight is 34. Then SRC is 2, dest is 1, and weight is 10. SRC is 2, dest 3, weight 20. Then SRC 3, 2, dest 2, and weight is 20. Then SRC 3, dest 4, then weight is 25. Then SRC 4, dest is 3, and weight is 25. Then SRC is 4, test is 1, then weight is 34. Then it just asks again, I'm just giving quit. Because as we seen before, if we just give quit, then everything will break, the statement will break. So I'm just giving quit to exit from the statement. See, if I just give quit, it just exit from the statements. Thank you guys.